Hey guys, welcome back to our YouTube channel where we teach you AP Chemistry. You're here with Mahleej and Janiya. Let's unlock the secrets of chemistry one molecule at a time.
How tightly an atom holds its electrons tells its secrets, and we can measure them. We've seen how electrons have homes and move in shells, but now ask, how tightly are these electrons held? The answer is ionization energy, and scientists can actually measure it using photoelectron spectroscopy, or PES. Ionization energy, or IE, is the amount of energy needed to remove an electron from a neutral atom. In my case, it's the amount of energy needed to remove one of Jenia's 12 Doritos Locos Tacos from her hand.
Okay, so we're moving like that. So then in my case, it's the amount of energy needed to prevent Mahleej from walking into the nearest Dunkin'.
Okay. Outer electrons, or in other words, valence electrons, are easy to remove because they have a low ionization energy. Inner electrons are harder to move because they have a higher ionization energy. A good periodic table tip to know is that ionization energy increases across a row. Because electrons are closer to the nucleus, there is a stronger pull. Ionization energy decreases down a column. Because outer electrons are farther from the nucleus, there's a weaker pull. For example, sodium has one valence electron, so it's very easy to remove. It has a low ionization energy. Neon has a full outer shell, so it's harder to remove. It has a higher ionization energy. Photoelectron spectroscopy, or PES, is like a metal detector for electron. And this is how it works. It shoots high energy light, or photons, at atoms. Electrons absorb the energy and are ejected. Measure the energy of the ejected electrons, and that tells you how tightly they were held. These are some key points that photoelectron spectroscopy can tell you. Energy levels, it tells you which shell the electron came from. The number of electrons in each shell tells you the size of the peaks on the spectrum. So an example of a photoelectron spectroscopy is neon. It has a peak for 1s electron. The core is very tightly held, and a peak for 2s and 2p. Those were the valence electrons. They're easier to remove. So let's connect this to the periodic table. Photoelectron spectroscopy confirms what we see on the periodic table. Row number tells us how many shells, energy levels, and the column tells us number of valence electrons. So, ionization energy tells us how tightly an atom grips its electrons, and photoelectron spectroscopy lets us measure it directly. Together, they explain reactivity, electron configuration, and trends across the periodic table. In the next video, we'll start diving into periodic trends, valence electrons, and how these patterns explain chemical behavior.